So, good morning, good morning, good morning. I'm going to start just a little early, but that's okay if people come in a little late and join us halfway through. Okay, so here is a parametric equation. X is equal to t plus 1, and y is equal to t squared plus 2t. I want to graph it over values of t from -2 to +3. Okay, what I would like us to do in this example is I want us to make a table so that we get more practice at making the table. I want us to graph it by hand. I want us to then eliminate the parameter by hand, and I want us to verify the graph on a graphing calculator. Okay? I think we can handle those 4 tasks right now. So let's make ourselves a table first. If I make myself a table, how many columns am I going to need? 3, right? I'm going to need a column for t, a column for x, and a column for y. Okay, so not the straightest, but I'm okay with it. So t, x, and y. And we said that we wanted t values from -2 to +3. So -2, -1, 0, 1, 2, and 3. Yes? Okay. Then my x function was t plus 1. My y function was t squared plus 2t. Right? That way I don't have to keep scrolling back up and have somebody have a seizure that's watching the video on the line. Okay? All right? So if I plug in -2 in x, what do I get? -1. If I plug in -1, 0, 0, 1, 2, 3. Okay? We should make nice little pretty lines going through here, and there, and there, and there, and there. Okay? Then I gotta plug those t values into my y. -2 squared plus 2 times -2. 0. -1 squared plus 2 times -1. -1. 0 squared plus 2 times 0. 0. 1 squared plus 2 times 1. 3. 2 squared plus 2 times 2. 8. 3 squared plus 2 times 3. 15. Okay? So there are the points then that I can now graph. -1, 0. 0, -1, 1, 0, 2, 3, 3, 8, 4, 5, 6, 7, 8, 4, 15. I know that it goes all the way up there. Now, when I go to draw my graph, do I continue going past those points on the left and on the right? No, I tap the brakes. Actually, I hit the brakes, and I stop. At those end points. 2 of our 4 tasks are done. Okay. Next, we need to eliminate the t. So let me bring back what they were. X equals t plus 1 and y equals t squared plus 2t. How am I going to eliminate t? Michael. Okay, So you are saying over here, I want to go this x minus 1 equals t into the other equation. So here I would go y equals x minus 1 quantity squared plus 2 times x minus 1. Yeah? Okay. So then that would give me y equals x squared minus 2x plus 1 plus 2x minus 2. Yes? So that gives me y, oops, that gives me y equals x squared minus 1. Yes? What shape is y equals x squared minus 1? It's a parabola. Which way does it open? Up. Where's the vertex? -1. 0 comma -1. Yep, it's down 1 from the origin. Is that what we graphed? Yeah, we just took a slice of it. Okay, we sliced off on the left and we sliced off on the right. Okay, but we have that basic form. Okay, so it verified there. All right, now let's go to the calculator and verify it. Okay, so I need to have myself a graph, so I'm going to add a graph in there. My graph is currently in function mode. I need to get it in parametric mode, so I'm going to go Menu, Graph Entry Edit, and Parametric. That changes that over to parametric. My x value was t plus 1. My y value was t squared plus 2t. My t values were from -2 up to, there it is, +3. Are we okay with a t-step of 0.13? Yep, I'm okay with that. Yep. And there it is. What's the downfall with this one? Can't see the whole thing, right? Because of I'm only going up to 6.7, and according to my chart, those bottom two at t equals 2, it's at 3 comma 8, which is off of this graph, and at 4, it's at 15. All right, 4 comma 15. So let's adjust our menu, or excuse me, our window. X-mins, if I want to make it look just like the one on my graph, I got to count here now. 2, 4, 6, 8, 10. Okay, yep, so we'll stay at -10, stay at +10. I like to go by ones. Okay, my graph went from -5 up to 15, and it also went by ones. And there it is. There it is. Now I just got to shrink it up a little bit so that it fits down in the corner. There it is. Huh? So we verified it on our calculator. Okay? Okay? What I'd like you to do now is I would like you on your graphing calculator. Oops, yep, we did eliminate that. Yep, I'm looking at the wrong page. Okay? Using the graphing calculators, graph that function. Okay? And then we'll play with it for a little bit. Or you can type in the word pi too, and it recognizes it. Yeah, I learned that the other day. Oops, kept the brakes. Now am I recording now? Yep, well, I'm recording, but my screen is frozen. All right, so I should have gotten that, right? Okay? Right? But what's wrong with that? Does yours look like that still? No. Okay? So to me, that looks kind of like an egg, right? But if I do this kind of a thing, where if I go into my zoom and I scroll down here to zoom square, which is actually B. If I zoom square that up, if I square that up, it makes it be a circle. Right? What it does is it adjusts the frame so that it's a nice square picture.
Can you just change the window settings?
You could have changed the window settings too, yes, to make them be equal. Okay? All right? So there is my function. Okay? So let me get that onto this page. Now, what I would like you to do is I would like you to play around here with two different aspects of that exact same function. So first, what I would like you to do is I would like you to adjust your t values other than 0 to 2 pi. Okay, so first, oops, I'm still on that one. So first, I would like you to adjust these to something different. Okay? Then, second, I would like you to adjust your t-step to different numbers. And try different things there. Go bigger, go smaller. Okay? You know what I mean? Adjust it all around. So I am going to give you 6 minutes. Okay, so until big hand's on the floor to do that adjusting. Here's where we started. What happened if we changed our t value? So instead of going from 0 to 2 pi, what did we find? Go ahead, Kim.
I thought the circle got bigger.
The circle got bigger? Okay, so if what? Did you go higher or lower than? Higher. So you went something, so you changed this number in here to be like 35? Okay. What's really happening? It's just keep going around in the circle, right? So it actually went around the circle. Instead of going around the circle just once for the 2 pi, it went around the circle, I think now, so six times, so almost 7 times, right? Okay. All right. So that works. What if we changed it to? What if we change it to just 3? Then what do you think is going to happen? What do you got? What's our guesses? It won't be a complete circle. You should have been trying those. That's what we were doing the last 5 minutes. That should have been, yeah, hey, it didn't go all the way around. Okay? Right? It stops it short. It only takes that little part of a circle. Okay? So the t values are going to adjust what your figure looks like. If we went back here to this one, if I go back to this problem, this parabola goes on forever in both directions. Okay? Right? It doesn't just stop at those. We stopped it. We cut it off to just be this part. But the actual parabola would keep going on forever if I change my t values. Okay? So then now let's adjust our t-step. So I want to go tab here, go back here. I want this to go back to 2 pi. Whoa, whoa, whoa. I go back here to the calculator. Tab. Up. I did figure out that you can do 2 pi on your on your just by typing in pi. All right, so then now let's adjust our t-step. Okay, what did somebody change it to? 10. Okay, so if I changed it to 10, how many times is it going to calculate it? It disappeared, right? Because how many times did it actually calculate it? It only calculated it one time. So I'm only going to get a point. Because it's only going to calculate it at 0. Because then it's going to go out 10 more and calculate it again. Well, that 10 more is outside my 2 pi range. Right? Okay? So it would only, so if I do 10 there, it's only going to calculate it one time. So it's only going to see a point. And the point is so small we can't even see it. Okay? So let's bring it down where it calculates it a little bit more. So let's go. Come on. T-step of 1. Okay? Not as smooth of a curve, right? Okay. What if we went a t-step of 2? Yeah. Okay. And then it gets all funky there at the end. Why it looks like that? Because it's not calculating it as often. Okay? When we have a t-step of like 0.1, it's going, so it's starting at 0, and then it's calculating it at 0.1. It's plugging t in both x and y at 0.1, and then it's going to 0.2 and calculating it. Right now I have it where it's calculating it at 0, then it's going to 2, then it's going to 4, and so on and so forth. Okay? So it's, the t-step tells us how many times it's going to calculate. Okay? Now, some of you might have gotten some funky stuff if we would do both. If I would do, so let's move this thing back up here to 50, and let's go with a t-step of, no, tap the brakes. Let's go with a bigger t-step. Okay? So, and then what it's doing, and the reason that it's getting all funky like that, is because it's whenever it calculates it, then it connects it back to the last one that it calculated. So that's why it becomes straight lines like that. Okay? All right? So the t values here adjust how much we see of the graph. The t-step adjusts how often it calculates it. Okay? What I would like you to do now is I would like you to graph this one on your calculator, make a little chart to go along with it, and then I would like you to eliminate the parameter by hand. So eliminate t. All right, so there is that function graphed on the window settings of our calculator. The reason that I had you drop those window settings into that range is because if I try some different t values here, let's try like -5, okay? If I put -5 for a t value into x, that's going to be -5 cubed, which is -125, minus -15, so that's going to be -110, plus 1 is going to be -109. Okay, so it would have been way out to -109. Okay, and then if I put my y, or put it into my y function, that's going to give me -5 halves, okay, or -2.5. Okay, so would have been kind of out there. Okay, then if I would have tried, if I go back here to 0, if I put 0 in there, I get 1. And if I put 0 into y, I get 0. So it goes through the point 1, 0. Okay. Then, if I go all the way up to 5, let's say, so now I'm at 125, minus 15 is 110, plus 1 is 111, and I'm at positive 5 halves. Okay? So it wasn't necessarily the easiest one, but we can just adjust our window. Okay? Then I asked you to eliminate the parameter by hand. Okay? So my two equations again were y equals 1/2 t. If I solve that one for t, that gives me 2y equals t. And I plug that into my x equation, which was t cubed minus 3t plus 1. So that then is going to be x equals minus 3 plus 1, and then that's going to be 2t and 2t. Oops, I forgot the cubed. Okay. So then that becomes x equals 8. Whoops, I put t. That should be y. Come on now. Not adding t's, I'm taking t's out, man. So that gives me 8y cubed minus 6y plus 1. Okay. Which is a cubic tipped on its side. Tip me over and pour me out, because it's y cubed instead of it being x cubed. Okay? Which is what we get there. Alright? Great place to end. You can leave the calculators on the tables. We'll pick this stuff up on Monday.